This is a demonstration of how an activity using electromagnets would look for students and why it would be important. In a lot of universities, physics is a required class for the engineering programs, and for most physics classes, there's a unit in electromagnetic fields, and electromagnets are directly related to the electromagnetic field formulas. And this is one of the main formulas that I used in my Physics 2 class for that unit. The B variable is the magnetic field strength. The mu variable is the core material. For reference, air is about 1. For this nail, it would be 1,000 to a few thousand, depending on the exact type of metal. And then N is the number of turns, and that's going to be how many times we wrap the copper wire around. So we want to get a pretty high number for that. And it's important that we're using enameled copper wire, which just means that there's an enamel coating on it. With bare copper wire, all of the turns would touch themselves, which means that it would just act as one turn. And then I is the current that we put through it. So the amount of current that we put through it directly increases the field strength, and L is the length of the nail that we cover in the wire. So we want to cover a shorter portion of the nail in the wire as opposed to a longer portion, because it's divided by that, so it decreases the field strength. And I'll show how students could test and see if the electromagnets are working. This is the first way we could test it, which is just hooking to a battery. This is a C-type battery, which can be found at a lot of stores pretty easily. And with this type battery, it has enough current where we can barely lift something like this socket. It lifts paper clips. It doesn't have a whole lot of strength, and I mean the strength could be increased by increasing the number of turns or getting a stronger battery. And what I think is the ideal way of testing it is to use a power supply, although power supplies are a good bit harder to get than batteries. So for the power supply, we can directly increase and decrease the current and see how that affects it. For a current of about 1 amp or 0.1 amps, that's enough to barely lift a paper clip. For something heavier, it doesn't really work. If we increase the current up to about 1 amp, then we're able to lift the socket pretty easily. And if we increase it more, then we'll be able to lift heavier things pretty easily, along with, it'll increase the strength by a good bit as we increase the current, because it's being multiplied by the amount of turns. And as we decrease the current, we can see that it gets a good bit weaker and is no longer able to hold the socket or the other heavier objects. So it's a good physical activity to do for students to see how the formula relates to kind of real world uses, and it's pretty easy to set up and put together, because you really just need the nail and then wrapping the copper wire around it along with a battery at the easiest case. And that is it. Thank you.